Welcome to this tutorial on suspend functions in Kotlin Coroutines. Suspend functions are one of the most fundamental concepts in Kotlin's approach to asynchronous programming. In this video, you'll learn exactly what the suspend modifier does and how it enables coroutines to pause and resume execution efficiently. By the end of this tutorial, you'll have a solid understanding of how to write and use suspend functions in your Kotlin applications. A suspend function is a special type of function that can pause its execution without blocking the thread it's running on. This is the key distinction that makes coroutines so powerful. When a suspend function pauses, the thread becomes free to do other work. Later, when the suspended operation completes, the function can resume from exactly where it left off. This approach enables efficient asynchronous programming because threads aren't wasted waiting for operations to complete. Instead, they remain available to handle other tasks, leading to better resource utilization and more responsive applications. To create a suspend function, you simply add the suspend keyword before the fun keyword in your function declaration. This modifier tells the Kotlin compiler that this function has the ability to suspend execution. In this comparison, you can see a regular function on the left and a suspend function on the right. The only syntactic difference is the suspend keyword, but this small addition fundamentally changes how the function behaves. The suspend modifier is a signal to both the compiler and other developers that this function may pause during execution and should only be called from appropriate contexts. There are three important rules to understand about suspend functions. First, suspend functions can only be called from within a coroutine or from another suspend function. You cannot call them from regular functions. Second, suspend functions don't block the calling thread when they pause. This is crucial for performance, as it allows the thread to continue doing other work. Third, when a suspended function resumes, it can do so on any thread, not necessarily the same thread it was running on before suspension. The coroutine dispatcher determines which thread will be used for resumption. Here's a practical example of a suspend function. The fetchUserData function is marked with the suspend keyword and takes a userid string as a parameter. Inside the function, we call delay, which is itself a suspend function that pauses execution for a specified time. In this case, 1,000 milliseconds. The delay function simulates a network call or other time-consuming operation. After the delay, the function returns a user object. Notice that the delay doesn't block the thread. Instead, it suspends the coroutine, allowing the thread to handle other work during that 1-second wait period. Since suspend functions can only be called from coroutines, you need to create a coroutine context to use them. In this example, the main function uses run blocking, which creates a coroutine scope. Inside this scope, we can call our fetchUserData suspend function. The call looks just like a regular function call, but under the hood, the coroutine machinery handles the suspension and resumption. After the user data is fetched, we print the user's name. Remember, suspend functions must always be called from within a coroutine scope or from another suspend function. Attempting to call them from regular code will result in a compiler error. The suspension mechanism works in three distinct phases. First, the function begins executing normally, running any code before the suspension point. Second, when the function reaches a suspension point, such as a call to delay or another suspend function, execution pauses. The coroutine state is saved, and the thread is freed to do other work. This pause can last for any amount of time depending on the operation being performed. Third, when the suspended operation completes, the coroutine resumes execution from exactly where it left off. The saved state is restored, and the function continues running as if nothing happened. This entire process is managed automatically by the Kotlin compiler and coroutine runtime. Let's recap the essential points about suspend functions. The suspend keyword marks functions that can pause and resume their execution. Suspension doesn't block threads, which is what makes coroutines efficient and allows for better resource utilization. Suspend functions must be called from a coroutine context, either using coroutine builders like launch or run blocking, or from within other suspend functions. Finally, these capabilities enable efficient asynchronous programming in Kotlin, making it easier to write code that handles long-running operations without freezing your application. Understanding suspend functions is fundamental to mastering Kotlin Coroutines and building responsive, efficient applications.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.